Just this. Here we go. Just give me a minute to stay on your screen.
Okay, cool. Hi everyone. Hope you guys are all good today on a Thursday afternoon. Okay, cool. I'll be talking about Java and blockchain. Who's ready to make money? I promise you, I'm not gonna scam you or anything like that. And unfortunately, I'm not here to make money, make you make money. But we will be talking about the technology that is in blockchain and how all this Ethereum networks, Bitcoin actually work, and how you can utilize that in Java. Cool. But before that, a bit of a history lesson. We have Web 1, right? And that came out probably in the 80s or 70s. I can't really remember. I wasn't alive at that time. But that is essentially the time when the web came into being, right? So that's when you could actually see something on a public address, access it and see a web page. But it was static at that time, meaning that you couldn't actually go on the web page and change it. So you can't go and say, hey, I like a web page, just like how you would do when you're commenting on someone's web page. And we have been most of my life has been in the web too, where now we have people being able to comment and actually interact with web pages. So now they're mutable. You can actually go and type something, it gets stored on a database somewhere, and then someone else in the world can see it. Right. So that was Web 2. That's where you get your Facebook, Twitter, and so on and so forth. Now, we are briefly moving to Web 3. And yeah, it is actually one of the most difficult moves, if I have to be honest, because it has a lot of confusion. People are not really understanding what Web 3 is, and because it's a technology that is very powerful but also very deceiving at the same time. You find that the ones who want to move to it, they'll be deceived and they eventually don't want to move to it. But hopefully today you will understand what Web3 is and why it is actually good for us. Cool. Now, Web3, as you see in the slide before, is that we own, meaning that Web3 is hosted on our laptops and computers and mobile phones. It's not, you don't have a company that's actually hosting Web3 servers out there. You could argue that you do, but that is not the purpose of Web3. The purpose of Web3 is that you could have your own laptop and host a whole network with other people in the world. And then you get a distributed network of about 2 million, 5 million, 10 million computers that are actually hosting a network that people can work from. And from this, we get that if something changes on my laptop, it gets distributed to the whole majority of the network. And it makes it much more safe. I'm going to put it in quotes because it's still experimental because it's not that old, but it makes it extremely difficult to hack such a network because there is a consensus mechanism that's in place to make sure that such doesn't happen. So if we have 10 million computers that are hosting the same kind of data, then you are. Yes, it's on. If you have a series of 10 million computers hosting the same kind of data, you're going to need to hack at least 5 million of them for you to be malicious in that network. Okay, so how does it work? Why is it so difficult? So in blockchain, we have a chain of blocks, just as the name says, blockchain. And each block has hashes of the previous block. With hashes, I mean that there's a SHA-256 algorithm that has to take place every time a new block is added. And with that 256, that SHA-256, it takes all the data in the block and then SHA-256 it. And hashing essentially just means that you're taking the data and you are using a mathematical algorithm to have a unique identifier for it. So that data will always have that unique identifier. That's what makes SHA-256 so powerful. Um, that's the first case, it's deterministic. Same input always outputs the same output. And also, it's also the probability of generating the same hash is extremely small. Although it's possible, the possibility is very small. So you shouldn't be worried about that. So that essentially means that if I was born at a certain date, at a certain DNA and so on, my fingerprint could actually be a Shaft 256. Does it? There are people in the world that have the same fingerprint, but it's extremely rare to find such an individual or individuals who have the same. So we can look at this as a identifier, and in this case, it's an identifier for a block. So every time a block is added, it is an identifier for the previous block. So what makes it powerful is that you find that you have 1,000 blocks right in this chain, maybe 10,000 moves over to 100,000, and as the chain grows, 100 million, blocks that are in there. And when you change one block in there, that means that you need to change the since the data in that block changed, the fingerprint needs to change. And then since each block is dependent on the fingerprint of the previous one, then you're going to find that all of these blocks have to change. So if you're going to hack a network, you're going to have to hack each block for that to happen. And then it brings us to, okay, this is just a representation of how a hash looks. It's a long, it's a long number. But now, what I want to explain is that we have this whole network of computers, phones, desktop computers that have this 100 million of blocks stored onto them. And for you to hack it, you need to hack at least 50% of them, and you also need to change each block so that it changes the previous hash for all the blocks. You know? So that is a lot of work. And what's been done with the beginning of Bitcoin is that there's something called proof of work, which is when you have a mathematical problem that has to be fixed, and you have computers that have to fix that problem. Bitcoin made it very hard for a single computer to solve it. It takes a very long time to do that. And once it's fixed, that's when a block is added. Right. To give you an example, this number over here, let's say the mathematical problem was that the first eight zeros the first eight digits, for example, have to be zeros. As I said, the SHA-256, there are situations where you would find that there are some converging results. So you could find that one data set has multiple equivalent fingerprints, but then the fingerprint that Bitcoin wants is one that has eight zeros in the beginning, and that will take very, very long. I've tried it on my PC. I slept for 2 weeks. I couldn't get it back. And with a distributed network, it distributes that workload between the whole network. You know, so that's another thing that makes it extremely difficult to hack such a network. Okay, cool. So now we have popular networks that we know of. I'm sure that a lot of you have heard about Bitcoin, Ethereum. Out of curiosity, who has actually interacted with such networks? Okay, we have one over there, two. Okay, okay, cool. That's not bad. 1% is not bad. 1% of the audience. Hopefully, after today, it will turn to five. But yeah, let me just speak briefly about Bitcoin. Just out of curiosity, are you interacted with Bitcoin or Ethereum? Ethereum. Okay. And that side? Same. Okay, cool. That's really interesting. And good, because I'll be speaking about Ethereum. Bitcoin is just, you know, it's a coin. But I'll also be explaining the difference between the two. So we have Bitcoin and Ethereum. And as you may have heard, Bitcoin is known as the gold, digital gold, something like that. And I wouldn't say it's a lie, because you have people who mine such treasure on the digital network. You have companies that go and set up rooms bigger than this, set up with GPUs just to mine Bitcoin, and that's the gold in it, because every 10 minutes or so, that a new Bitcoin is mined, and that it doesn't and there's a limit to how many Bitcoins there would be. So once you mine all of them, the people who have Bitcoin would not be able to get more unless they swap it between each other. So that's why it's called the digital gold. It's just like on Earth, we cannot have more gold than we actually have unless an asteroid or meteorite comes. Hopefully, it doesn't kill us. Okay, so yeah, Bitcoin is a digital currency, and then Ethereum is a decentralized virtual machine. We all know virtual machines. We love and use them when we do not want, to install certain softwares on our PC. So we have actually certain dependencies that we cannot install on our PCs. It will interrupt our workflow. Now, with the decentralized virtual machine, it is a platform that Ethereum came up with that allows people to run code. Code that is what you call it. I can't remember the phrase. Oh, Turing tested, something like that. Meaning that it cannot be. It's code that can actually run all possible situations that you can actually have. Just like Java, you can go and write Java code. With the code that you can run on Ethereum, you can do the same. There's no limitations. The only limitations is the gas, which I will get to that just now. And with the decentralized virtual machine, it means that once you write code on this virtual machine using Solidity, that's the language that's used for Ethereum, you can run this code on people's PCs. And as I said, with gas, to run it on people's PCs, you pay gas, you know, and gas is the coin that is used by Ethereum, which is called Ether. So we have Bitcoin, which is digital gold, and then we have Ethereum, which is a coin as well, but it's a coin that is used to run software on the virtual network, which is essentially the whole world. Anyone who can run a computer or can run a desktop, even phones these days, you can run software on their phones, utilize the CPU for a certain app that you want to do. So now we're changing from getting a hoster, a company that hosts certain stuff, to having the whole world to be a host, even a mobile phone to be a host for your software. All you need to do is pay the gas. Here's an example of Bitcoin's proof of work. I'm telling you, no one is really happy about how it's going at the moment. Ethereum used to be like this as well. I'm a gamer, I play games, and because of this, the cost of GPUs, graphics cards, has been skyrocketing all this time because people will actually buy bulks of these graphics cards just to mine Ethereum, Bitcoin, or any other altcoin that is out there. And it hasn't been well for us. I'm speaking sympathetically here because I'm an avid gamer, but it's changing now. Even though Bitcoin is still proof of work, you get that the majority of developers are working on Bitcoin because Bitcoin gives you so much flexibility in terms of you can build your own apps, decentralized apps on Ethereum. So we know Bitcoin as a coin, right? But you can, if you decide and if you are really motivated to do this, you can go and create your own token. I didn't say coin, I said token because tokens are contracts that run on the Ethereum network. So now remember, Ethereum is this network that you can go and put code onto it. Now that code, there is a standard called ERC20, and those are ERC20 contracts which you can turn into tokens that you want to actually make them valuable, depending on the cost. And to give an example, there's a token. I use a browser called Brave, and they have a attention token, basic attention token. It's an ERC20 contract, and every time you see ads on Brave, you get the token. How much it's worth is based on how much people actually think it's worth. That's the whole point of decentralized networks. But at the end of the day, you find that I can rock up maybe $2 a month just because I saw ads, and that is the beauty of decentralized networks. You can go and pay certain tokens based on what you think is worth it to have a token for. And yeah, you can replace the rand if you want. Now, difference between proof of work versus proof of stake is that, yeah, as you can see, proof of work, you're busy digging there, you're mining for certain tokens, and proof of stake, which is what Ethereum moved to um, in September last month. It is when I have stake in Ethereum, so I have a certain amount of Ethereum, and the probability of me mining a certain transaction that's on the network is it's based on how much stake I have in Ethereum. It's not as perfect as proof of work, but they're still improving it. Not that it's bad or anything, but it's good in a sense that it is good for the environment. You don't need to use that much energy. Okay, just to explain, I'm going on a rant about blockchain so that we understand where I'm going with this blockchain thing and how it fits into Java. Also making sure that everyone is on the same page with what you can do with smart contracts and Ethereum. Okay, I've explained the okay, well, contracts. I explained the ERC20 token. Even though there's ERC20 there, doesn't mean that we are limited to that. We can build any token. We can build any contract that you want. So ERC20 is the standard for tokens. You know, buying, selling, transferring, all that's the standard. We have NFTs, ERC721, which is also a standard. Um, but you can go and build your own custom contracts as well using Solidity. Solidity is the language that's used to deploy this code onto the network. When you type it in, it gets converted into bytecode, and then that goes into the network. And it gives people an opportunity to interact with the contract. And for them to interact with your contract, they need to use gas, and gas is the token that Ethereum, sorry, not the token, gas is the coin that Ethereum is using, and it's called Ether. So when you buy Ether, you are able to interact with the tokens using it. That's essentially how they make money. Now, with the Java 3J, there is a way for you to interact with a blockchain network. Blockchain networks um, come in different flavors. We have Phantom, we have Ethereum, we have Bitcoin, and the one I'm concentrating on today is called Ethereum. Though we have Phantom and Solana and so on, they're still based um, on the same model as Ethereum, and that's that you can build a Solidity contract and then deploy it. Now, Web3j is a library that you can use in Java to interact with such a network, and it does it through JSON RPC. And it's a standard that all these networks use to communicate with any client. So, I mean, I'm going to go off topic now, but then when I say clients, I mean we have custodial clients, we have non-custodial clients, these words. And then with custodial clients, it means that you have someone that you depend on to store private keys that are important for you to interact with the network. These private keys, you can look at them as the your password to your bank account. So let's say you're using a non-custodial wallet. It essentially means that you are the one responsible for your private keys, just as you would be for the bank. Now, but the difference right now is that the bank owns your money, and if someone actually hacks into that, it's your bank's responsibility to make sure it doesn't happen. Since this network is it's decentralized, no one is really responsible if your account gets hacked, only yourself. And with non-custodial wallets, it just means that the private keys for your wallet get stored on your computer, phone, whichever device that you're using. You will get a unique ID, unique address that you can store somewhere. I usually store mine in. I almost said where I store mine. Okay, I'm getting carried away here. Yeah, you store it very safely. Make sure no one gets to it. So that's something that you shouldn't get anyone to get to. Now, With JSON RPC, you can build applications that can interact as either custodial or non-custodial. And let's say, let me make an example. If I was going to build a custodial one, I would probably require an API. And on that API, I will store the private keys of the user on a database somewhere, right? And I will obviously make sure it's secure and no one else can get to it. Now, the communication between the network and the user's application has to be from the network to the API and then to the phone, right? Or the desktop if they're using a desktop. However, if it's a non-custodial one and the user is can actually willing to take responsibility of storing the keys, then the communication will be from the RPC, well, this library directly to the network that has to be spoken to, right? So that's the difference between custodial and non-custodial. And this library can do both of those. And what can you do with this library? So you can deploy contracts. I wouldn't recommend that you do it through this library. There are many libraries out there that have been written, hard hat, truffle, that makes it very, very easy for you to deploy contracts and also for debugging such contracts when you deploy them. Primarily, I think that it's important to use such libraries because they give you the ability to debug. And debugging is important with this because um, Ethereum networks or any blockchain network is it's immutable. You can't go and deploy something and then you see there's a bug and then you have to change it. You can't do that. It's going to be a new contract. I know it's a nightmare for developers, but it is what it is. Once you deploy something, you cannot deploy it again. It's going to be a new app, a different app. So look at it as it's the Play Store or Apple Store. Once you deploy an app, you can't go and send an update, but you will have to name it differently and have a different app and just forget about the one that you've already deployed. Um, and the other things you can do is interacting with the contracts. So these contracts, they have methods, just like Java, you have public, private, protected methods that you can interact with. Same thing with Solidity contracts. You have such methods, and since they are distributed in the network, anyone can have access to them. Obviously, the private ones and the protected ones, they will not be able to call them from outside the network, but they will be able to see the code of that contract. Publicly, they can call the ones that are set as public. So, for instance, the ARC20 contract, I should be able to see how much I have in my account, right? So I just give it an address and I view that. And now, because of that mechanism, where it's a public method, it means that anyone who has an account on Ethereum, if the public key or the address they use to identify themselves is shared with anyone else can see how much they have in their account. It's not a security threat or anything like that. It just makes everything much more what's it called, open for everyone to see. But there are fixes if you are actually a person who doesn't want people to see how much they have in the Ethereum account. I don't know what kind of person that is, so I want to share my accounts with everyone and see what they have. That's a joke. Yeah, that's the whole thing. It's open for everyone to see. And then the auto generation of smart contract wrappers is that you have, since contracts are deployed on Ethereum with bytecode, you can't really just download the bytecode and then call whatever method that you want. But this Web3J allows you to do that uh, based on the flattened code that you have of the contract. And it will generate Java wrappers for you that you can call for each method, which is quite useful. So the balance of method that is on ERC20 contracts can be compiled into a Java file, and then you can just call that in Java and get the balance of a certain address. You can transfer it to a certain address, And to give you my background, I'm actually an Android developer. I've been developing Android apps since the early 2010s, 2010 somewhere there. So I'm actually quite a fan of this library because it's Android compatible. That means I can build any software for Ethereum using this library. And here, the one that I skip support for Alchemy in Fura, it just essentially means that you don't have to run an Ethereum client yourself. I would actually say that you should rather run it yourself before you go to Infura. What Infura and Alchemy do is that they are a network, but they are not mainnet. And by saying mainnet, I mean that it's not the real money that you're working with. It is fake money. So before, as I said, it's very difficult for you to test this apps, right? And once you make a mistake, you can't take it back. So it's best to maybe go and deploy this on your own local machine, spin up your own Ethereum network yourself, and then once you're comfortable with where it is, you go to Infura and Alchemy and deploy it there. And those are called test nets. And test nets are networks that simulate the main net, which is the one that actually is real money. And on Infura and Alchemy, that's where you can test with any, your friends or anyone you work with to check if this smart contract is behaving as it needs to. And you have nothing to lose because it's fake money. You get your tokens or coins from um, a faucet that you can email the guys who are running um, this programs, Alchemy and Infura, and they will give you a certain amount of coins. Did I do that? It's me. I wasn't gonna be surprised if it was me. Okay, moving on. So the issue of gas, right? That's the other thing that you need to consider if you are building this types of contracts. So as I said, we have these distributed computers out there, and what's in for these people to be running a certain software just to run your software? What is it? What's in it for them? And that is gas. So if you someone on Ethereum, or you build a smart contract, you essentially pay gas to deploy this contract, and that's anyone who has to make a transaction on this network has to pay that gas. Let me think of a simple way to explain. So I built my contract. Let's say it's Home Affairs, right? And we want to build a contract that is going to be used for the title deeds to make sure that the title deeds are immutable. So firstly, to deploy the contract, it's a transaction. I'm sending bytecode over to the network, and that bytecode has to be converted into a contract, and someone has to be responsible for doing that. So, in the tens of millions of people who are on the network and having the computers ready to compute such stuff, they have to be compensated somehow, and they get compensated with gas. And gas is the it is the coin of Ethereum. So, essentially, if I deploy such a contract, someone in the world would get this gas for, I would pay maybe $2 or something, but that $2 will either get distributed between certain amount of people who have allowed the computers to do such computation. Um, yeah, and then that's how the network actually works. And then once the contract is there, and then you need someone to actually view if they exist on the title deed system. Maybe they're going to put in a certain ID and then view if they exist there. That's gas as well. So that will be computed by someone else and so on and so forth. So that gas is used to compute information on the network. As much as we can look at gas as the electricity of the network. We use electricity for our computers, and we require gas for computing on this network. Okay, looking at the time now, I think I should be done. Yeah. So just the next slides are just going to be links on what where you can get more information about certain technologies that I spoke about. But then here it's Ganache. It is you can use it for deploying contracts onto the network. You can use it for you know any network that you want to. If either it's mainnet or it's not mainnet, you can use that, and it's owned by Truffle. And Ganache, you can open it up to also simulate a network on your own machine. So when you're busy testing there, this can be used to simulate a blockchain on your own machine. And I have some useful links. I figured that it might be easier to have a QR code here um, to get links of the Web3J where you can actually get the library and code Java and Web3J. Troubleshoot and Ganache are also available there. So the troubleshoot is what you use for the deploying of contracts and viewing the state of the network, and then Ganache is what you actually use for spinning up a network yourself. So yeah, I will, yeah, we have this link, so you can just have a look. Which one should I stick to? The QR code and this one. Okay, cool. Thank you. Thank you, everyone. My name is Melvin. Are there any questions?
Excuse me. Sorry. I don't know if you've been watching the news lately, like after the 15th of September. The narrative has been Ethereum will be 99% eco-friendly because of resource wastage, right? That's every citizen, every check, that's kind of the narrative. Ethereum is going to be eco-friendly. However, all that processing power that we're using to mine Ethereum is obviously going to be used to mine Ravencoin and Dogecoin. So we still have that's the exact same amount of energy usage. So in effect, we aren't eco-friendly at all. It's just the way I see it is kind of like energy contracts where they say you're allowed to um, emit this amount of CO2, and then you can swap the contract so you can emit more. So
Mhm.
I don't know, I feel like they're kind of being sneaky.
Yeah. No, I get what you mean. What you're saying is true. So, like I said, I'm a gamer, and I realized that a lot of people have been buying graphics cards, right, for this essential work of buying Ethereum, well, mining Ethereum, mining Bitcoin, and so on. And to be honest with you, like, it's not as popular. So as much as we have people who already own this hardware and they are able to mine using it, I mean, they're left with no choice. They bought their hardware, they need to use it now for something. But the thing is, we are at a point where we have people who are not buying more hardware anymore. So we were using this much and we've stuck there where we could probably even be using less, but we're not going higher anymore because the era of actually mining Ethereum has ended. And a lot of the altcoins are running on Ethereum. So because of that, you find that thousands of people cannot mine what they used to mine before. After the proof of stake, or once we merge the proof of stake, people are not mining what they used to mine. So it's still we are saving energy now.
In the long run.
Sure.
Thank you so much. Can we just have a round of applause?